Okay, so we have two topics now on private and public keys. One is an overall introduction, and the second one is a very important is a critical concept we have to cover. So private, public, or address, private key, public key, or address. This shared pair here this is the building block of Bitcoin. This is the one of the main ingredients. So when you have a public address here, once somebody sends Bitcoin to that address, within roughly 10 minutes, all the data in that transaction, to include your address, will be permanently stored on the blockchain, publicly available, permanently stored forever. There's also another piece called the transaction identifier, which is also going to sit in the UTXO database. And then when it comes time to spend this Bitcoin, that in another transaction you want to do, it's your corresponding private key that will unlock that Bitcoin that'll enable you to do that next transaction. So here shortly in an upcoming video, we're going to walk through how to use this website to make our own private public key pair using bitaddress.org. So again, Bitcoins live at this address, and this is just the QR code version of this string down here. And whoever owns this corresponding secret key can prove ownership of any Bitcoin at this address. And of course, these two numbers are mathematically related. So this private key is a 256-bit random secret number, which is just 256 zeros and ones in a row. And to make this pair, Bitcoin starts off using the elliptical curve digital signature we've covered in a previous video. So this private key is this value here, Y, and the corresponding public point, and this is the corresponding public key point on the elliptical curve. And only the X value is used. This is a 256-bit value. It's going to go through this process to end up here as a displayable Bitcoin public address. These three pieces here, this process is also a significant security feature. So elliptical curve, SHA, and ripened are all stand on their own as irreversible functions. And they also go about this in very different ways, very unique flavors. And interesting point is that SHA-256, as well as most of the major hash functions out and about, were developed in coordination with US or other nations' intelligence services. The only mainstream hash function that was not developed by some kind of national intelligence agency is ripened 160. So there's a little bit of flavor in here of distrust. This was built by European academics. So when you give this address to the public world, when it goes to the blockchain and it's available to everybody, the link from this back to your private key has three powerful, unique encryption techniques. And really the idea of this is to future-proof these. And let's recall also the brute force option, that if you want to to determine this number, given this number, you want to do brute force, you'd have to guess and check about 2 to the 256 times. We'll divide it by 2. And this is the same number of atoms in the universe. This is a ridiculously large number, and the size of this number is beyond comprehension. This is the guessing and checking is the same thing as buying a Powerball lottery ticket every day, and then you're going to win the Powerball 9 times in a row. So back to the process. Then this process also saves space on the blockchain. Only the X coordinate is used, total amount of bits are reduced, and so on. And then when it comes to the base 58 check, we're going to need to digress for a minute to cover what this is and why it's such a good thing. So there are two things going on with base 58 check. First one is the check, and the second one is called base 58. So the check here, it starts with the public key hash. This is the 160 bits you get out of the ripened after the SHA, after the elliptical curve. And first thing you're going to do is add 2 zeros to this. And we'll see in a few minutes how this will translate to the letter 1 at the start of all of our public addresses. And there are other Bitcoin address types out there, but by far the most common one, and the one we're definitely going to start with, is this one here that starts with a 1. So we have this whole value here is put through SHA-256 2 times in a row. You take that output, take the first 4 characters, 32 bits, and add it to the end of this. And now you have a 200-bit Bitcoin address. And let's look at the check piece of this and why this is important. So when the Bitcoin software receives this address, it's going to take these 168 bits, it's going to run it through this same process, and it's going to compare the value that it gets to the value that you've given. And if you made a typo or somehow a bit got messed up in transit, whatever the case may be, if there's an error, you're going to get a different value here from these hashes. So the software is not going to send Bitcoin to this address if it's an invalid address. So essentially the software catches the typo and protects you. It protects the user. And likewise, if you have an error in these last 32 bits, it's going to be caught as well. And then, so now moving on to the next step, which is the base 58 portion of the base 58 check. So with computers, software, hardware, these are the most recognizable bases. And base 2 is just the ones and zeros, the binary. And we have base 128 is the AC standard. This is the one most people have probably seen somehow, somewhere. These are all the symbols that are on our keyboards. And over here, these are the various control functions for data transmission and data processing that our machines use. And AC uses groups of 7 bits, and it's just a protocol, it's a rule. It says we're going to represent these 7 bits as the capital letter A, as an example. And then this all comes from the original hardware and software when the internet was being born. And we had the typewriters at the time. Looks like that. And it says these had well less than 128 characters. And the 8-bit hardware at the time was also very common, but the protocol only used 7 of the bits because the 8th bit was needed to double check accuracy. I added in a base 10 decimal, and most people are probably not too familiar with these, the base 10, the base 16, or the base 64. But these are very common. These go on behind the scenes in our machines all the time. They also happen in specialized hardware or software. These things are used all the time. And in hexadecimal, with hexadecimal and base 4, these are also, it's very easy to just visually look at the binary, the bits, and you can quickly tell the character that represents those bits. It's very straightforward. But we do need to go through an example so we can see the math of how these bits get converted, to a value, which then gets converted using the table to the right character. So in this example, we're going to convert our binary here, which we already know the answer. We're going to convert it to base 64, the 2-step process, and you can do this by hand too. So you use this table, and this is just listing the powers of 2 from right to left. Add in the locations where your bit is a value of 1, and add those together, and that gives you your base 10 answer. And then we take this back to modular arithmetic, but apologies, we need to stop right here. I'm gonna increase the difficulty of the example. So I'm just gonna add in 3 more bit locations. That way you can see the second piece will make a little more sense. So I added in 3 more bit locations, converting to base 10. This now gives us a base 10 of 468. Once you have the base 10, you can convert to any other base. You just take the value. You take the value of the base, in this case 64, this becomes the modulus. You divide and take the remainder. So 468 is divisible by 64 7 times, gives you this remainder. And you keep repeating this until it no longer divides. In this case, you have remainders of 7 and 20. You go from the bottom to the top. And the corresponding values in the base 64 table will give you a capital H and a lowercase u. So the impact of this is if you have a binary number, you can convert it to any base with math. And there's also a math process to do this in reverse, go from any base back to binary, or also from any base to any other base. So now we come back here. These are the most common, but it does happen. You have a piece of software, hardware, protocol, or so on. For some reason, they need to create their own base. And they can have, and they'll assign their own characters to this base. And your computer will have no problems translating from binary or to the more, or from the more common bases to this special base. So that's what base 58 is. It's near identical to base 54, but it's simply removing letters that look alike, and it's also removing these operators. So this is the table of the 58 characters. I guess I can show that for more than half a second. And so here's why this is, the benefits. So one, it's easy to copy and paste. If you have special characters in your address and you go to copy it, it's going to split up the address. But if you have no special characters, you can double click the whole thing. Pretty simple, but still convenient. And then number two, you're not going to get some kind of address where all the characters look alike. It'd be very hard to input that in manually. So now we come all the way back to our flow chart. So base 58 is going to take these 200 bits, and then it's going to give us this 34 character string. And then a reminder, these 8 bits here, these are all zeros. So when you go through this math process, and you're going to get the value of 0, and that's going to ensure that the first character in our address is always going to be a 1. And there are also other letters or numbers that you might see at the start of a Bitcoin address. They're not as common. Again, this is the most common and definitely the one we're going to start with. So what the Bitcoin software is using are just these bits. So when you include the check feature in the base 58 conversion, you're not changing the bits. It's just making the address easier to see and interact with, and it's protecting against QR fades or typing in the wrong address, some kind of typo. And this process is used for private keys too. And it's the same for private keys. It's the same process. And again, you're not impacting these bits. There are no changes to these bits. And you'll see one of these here at the start of your secret key. And there are also other formats out there for the start of secret keys, but this is the most common, and this will be the one that we'll be seeing. So to recap, your private key is kept secret by 3 unique and each individually very powerful cryptography tools. The checksum is going to prevent accidental errors, typos, anything with transmission, making a mistake on the address. And it's the base 58 encode portion that's going to make addresses more readable. And these key pairs, these are the critical ingredient for Bitcoin. So that's why there are so many features here. It's increasing their performance. So to our last topic is exclusively about the secret random private keys, which again are the 256 zeros and ones. So there are 3 ways to make suitable random numbers, and one of them you never want to do. So let's start with the coin toss. And people actually do this. You take a coin, you flip it 256 times, and it works because when you do this process, it's completely not predictable and it's completely not repeatable. And the same thing applies if you want to use dice. You're going to get the same randomness and the same lack of predictability. Now when it comes to pseudo random number generators, these are not designed for security. Most random number generators are not designed with security in mind. I mean, they have many other applications. They do a lot of good out there, but when it comes to cryptography, they're the exact opposite of a coin toss. These are bad. So now on to the last one, bitaddress.org. The idea of this site is very useful, not only in Bitcoin, but in any situation that needs randomness. And it's common to take some kind of user input on a mouse or a keyboard, and it's just mapping the location where your mouse is or certain timestamps when it's at a certain area, and other input that is randomly generated by the user. So there's also other ways to get cryptographically secure data. So there is special hardware that can that can have natural and random fluctuations within that hardware and ways to monitor it. And interesting, there's also a company in California. They have a big wall of lava lamps, and they use the random movement of the lava in the lamp. They track that and they convert that into cryptographically secure random data, and people pay for that and use it in cryptography. But we're not going to do lava lamps. We're just going to stick with bit address. It's simple and it has everything that we need. So haven't done a meme in a while. So the bottom line is you must use bit address to make your private key until you're like a Bitcoin expert or you have some other compelling reason to do it some other way. So these key pairs, these are the critical ingredient of Bitcoin. Your private key and your public address, your public key, your public address, these are mathematically linked. The public key and the address, public address is widely known. If you get Bitcoin sent to it, this address is recorded on the blockchain forever. But your private key will always stay safe due to the cryptographic power, the three different flavors of cryptographic power between your public key and your private key.